Every customer has a use case for simulation, whether that be big or small. Most people start small. I did work with a company that was running some sheet metal forming, right? So prog dies, that sort of situation. We helped them understand and set up a tool so that they could figure out what kind of defects that they would see beforehand, wrinkles, tears, things like that you typically see in sheet metal. So that when they actually set the tool up and they were using it, it worked how it was supposed to do. There was no rework. There was no taking the tool down, rebuilding anything. It was ready to go. It's for everybody. It's for the big guys. It's for the little guys. One of the things that we at Dassault really kind of pride ourselves on is scalability. So we have solutions for people to just get started. If I'm someone that has no experience with running any kind of simulation, but I have a little bit of engineering background, I can jump right in head first, and I can get a pretty good understanding. Obviously, I would recommend training classes, but like you can just kind of poke around and you can get some answers. And then as things get more complicated, as the problems get more expensive, I guess is the best way I can describe it, we can also facilitate that.
Awesome. Well, thanks again for joining today's SWYFT chat. Today we've got Drew in the studio, and I'm excited to have this conversation. Obviously, Matt is here as well. Matt, sorry, today you're not as special as Drew because he is across the table, but excited to hear your input into some of this conversation today. Our topic is around simulation. So with that, as dropped in the center of the table, and let's start talking around it, Drew, give me a little bit of your background with product development, simulation, kind of how this all encompasses and why we're going to be talking about this today.
Yeah. Well, first, thanks for having me. So I've been using simulation softwares in various capacities for the last 16 years. That sounds about right. I started my career in product development, and I very quickly migrated into the simulation space, which is a very broad category that we are going to unpack as we're talking today. Though I've been helping companies in various capacities, from figuring out what manufacturing defects they're going to see before you actually make a part to the actual design of products. So I've been around this for a while. It's a topic that is near and dear to my heart, and I'm always happy to talk about it.
Well, thanks for being willing to do that today. Matt, what is your experience with simulation? Like, why are we at this table talking about new product development? You got an engineering background?
Yeah, so I got started more on the design side of things, SolidWorks, and I did do some, SimExpress is where I got started with my first couple of things, just testing out some linear static analysis on single parts, but I've gotten into some SolidWorks simulation, did contract design with SolidWorks, and some of those involved testing out various aspects of the design process and the product itself. And currently now I talk to people on the customer success side here at SWYFT and just make sure that as they're looking to move forward with their product development, what solutions we have available that could potentially fit into their process and help evaluate the best fit.
Matt and I have worked together for a long time, and we've had a lot of conversations, even from doing contract mechanical design and just straight up SolidWorks work together, where you'd work on a mechanical design and the client would say, well, let's just build it and break it and see what happens, right? And it is a process. It is something that can be incorporated into your new product development workflow. But what advice do you have for some of those companies that are out there and they're really just kind of getting into an understanding of where simulation could work within their workflow, and should they even be exploring it as an opportunity for product development?
Yeah, that is a great question. So in my experience, every customer has a use case for simulation, whether that be big or small. Most people start small. So to understand where it fits into the workflow, a lot of people like to think about it more in terms of virtual testing, which is a term that we use to describe simulation for a very long time in the industry, just because it makes sense. So like, I do a drop test. Well, I can simulate that in a virtual space, and I can see if it's going to pass or fail based on the criteria that we define. Maybe I have a pull test where I'm trying to see if this thing is going to stay on a station, something like that, from a structural standpoint. I could also look at this from a manufacturing standpoint. So there's a lot of what we'll call explicit manufacturing codes. So codes that predict manufacturing defects for a specific manufacturing process, like sheet metal forming, metal casting, plastic injection molding, metal extrusion, just like naming a few, right? Those are also simulations that we can run. We can also look at this from a term of like not just a physical product, but like electromagnetic simulation. That's something else that we can find, like figuring out what sort of magnetic fields are going to be affecting a part that I have. If I'm trying to figure out on a part where I want to place an antenna so that it doesn't interfere with anything else on the system, like there's millions of different applications for simulation and so many different places to start.
Matt, as you're thinking through different examples or different applications that you've kind of seen in the industry, maybe from a high level, some ways that you've seen companies incorporate simulation into their development workflow.
I'd say that the iterative workflow is where you see the most benefit. If you introduce simulation early into the workflow before you get too far, companies that introduce it too late, they go in, then they're almost to prototyping by the time they simulate, and then they find out that they could have changed it way back when. So having solutions that benefit you to that workflow also very beneficial. So getting in, design, get to a point where it's a viable product that you would even potentially make a prototype of, test, change, test, change, test. It makes a difference in terms of whether it's product development or if you're in the manufacturing field, but all the same thing. Test is as early and often as possible.
Yeah, even on the manufacturing side, right? I mean, there's some simulation tools with that. I mean, what are some of your thoughts on taking simulation outside of the even new product development process?
Well, I think that simulation can fit in just about any part of the product development cycle. It is obviously more traditionally associated with the design portion of things. When we're getting started, we want to make sure that our part's going to do what it's supposed to do. But understanding your manufacturing process and understanding it using a simulation tool is really beneficial for a lot of customers. It helps you save money, which helps you save time, which is the currency of manufacturing. So that is exactly what we want to do with it.
You're not making chips, you're not making money. I think I've heard a podcast or two say that.
Absolutely.
Yeah. So as you're thinking through, those opportunities for clients to incorporate simulation, either, simulating a manufacturing process or simulating whatever you want, flow, whatever. As you're looking at that, do you have got some specific examples of maybe some of the scenarios that you've seen clients incorporate?
Yeah, I will omit names as a legal safety net for myself, but I used to do some simulation work with actually quite a few companies out on the West Coast, specifically the Orange County area. I did work with a company that was running some sheet metal forming, right? So prog dies, that sort of situation. We helped them understand and set up a tool so that they could figure out what kind of defects that they would see beforehand, wrinkles, tears, things like that you typically see in sheet metal. So that when they actually set the tool up and they were using it, it worked how it was supposed to do. There was no rework. There was no taking the tool down and rebuilding anything. It was ready to go.
Can you tell me a little bit about without obviously getting too much detail, but the before and after, right? Like,
oh, yeah.
Before this was implemented, there was a pain there. There was obviously wrinkles. There was obviously issues, defects coming into the product prior to implementing this simulated solution. Can you dive a little bit deeper into that?
Yeah, absolutely. So this is a great before and after scenario. So before we got there, the design cycle, it depends on what they were doing, but it could take anywhere from 9 months to 2 years. And we got it consistently to about 6 months for every new tool. So it's one of those like easy things that you don't really think about, that if you can figure out what's going to happen beforehand, and of course, if you can figure out what's going to happen beforehand, you're going to save a lot of time and you're going to save a lot of money.
On that topic of thinking about what can happen beforehand, talk to me about you've been running simulation and you've been engineering, you've been in mechanical design for a long time. We brought that up already.
Indeed,
right?
I have.
Not super, super, super long time, but a long time, right? Long enough.
Almost long enough for it to be able to vote, yes.
Thinking forward, thinking the next 5-10 years out, what do you see potential changes? Give us a vision of what simulation can do today, but also potentially other applications that could be coming up in the future that, it's good to get an understanding of how you can leverage the tools today, but also to understand what the impacts could be in the future as well. What types of things could we potentially be able to simulate?
Oh, yeah. So the sky's the limit. There's some very interesting things on the horizon already, but I'll start with where we're at and where, in Dassault in particular's case, are going. So with a lot of simulation products and codes that you can run, it's a very finite set of things that you can do. It's limited within that specific discipline of physics. I'm thinking about structural engineers that are dealing with structural design. If I'm trying to understand a fluid problem, so fluid dynamics, typically that is sectioned off to its own thing. And that's not to say that Dassault limits you to those like disciplines. You can certainly mix and match and combine some of those simulations to get a better real world understanding, because the real world does not limit itself to specific engineering disciplines. It kind of does what it's going to do all the time. Now, that is a more traditional way that things are going. Where I see things going and where Dassault carries things into the future is interconnectivity. Interconnectivity and the combination of these sorts of things. So what is the more common like understanding that people have of this is what we call like Industry 4.0, like, you know, the Internet of Things, where everything's connected, you can get live feedback. We have a saying in the simulation world, and lots of people have this saying, but it's garbage in, garbage out. So if I have a bunch of information that I'm trying to feed into a simulation, so it's a better understanding of what I'm trying to get from a real world application, the more real world data that I can put in, the better results I'm going to get out. That's the predictor of accuracy. So having feedback in the real world connected to a simulation product, making it more automated, making it a better understanding of what you're doing is the future of simulation tools. And that is the direction that we at Dassault are going, for sure. But that is the direction that I see most of the industry going as well. It is making it more accessible and more connected so that the products that you are trying to make will be made more simply and will have less steps to get you a better result, if that makes sense.
Yeah, and obviously that's going to be driven by something, right? Like the need for leveraging those types of solutions are driven by either change in the way that we develop products in the future, or even pains that are faced today. What are some of those drivers that you see that could potentially impact the way that people are leveraging simulation in the future?
So the drivers for this sort of thing, obviously, and I'm going to keep going back to this, it's time. So we, and I come from also, design and manufacturing background here too. The entire currency is time. So I'm trying to save the amount of time it takes me to produce a product. The main driver for all of the changes that we make, all of the advances that we make on our software, and that anyone makes in their software, is to reduce the amount of time it takes to produce something, right? So if we can get immediate feedback from a test, if I'm trying to make more simulated results, if I can get immediate feedback from a designer and say, okay, this design is okay, I can make this change if I'm going to run a simulation on it. So it's not necessarily just an automated process, but a more connected process. It will help to ultimately save companies time and money.
Well, you start talking about saving time, I start to sit up in my seat and get excited, right? Because at the end of the day, that's like, you know, you can save money, but you can make more money.
Yeah.
Save me time, I have no way to make more time. And so that's something that's very exciting to me, being more efficient and making sure we're improving our ways. Matt, do you mind just talking into that microphone just quick? I just want to make sure it works.
I was just going to say something.
You're going to ask a question. Drew, we talk too much. Matt's just not able to. His microphone actually does
back.
work.
There's a couple of times where
Tripping.
Anyways, with the connected Internet of Things, aside from a couple of things that come to mind from testing is like material accuracy, being able to import data like that. But like what other areas, I guess in other areas like parametric design studies and having that feedback read back into it, but what other areas could benefit off of having that live feedback loop?
Oh, that's a good question. So we'll go from a structural standpoint, right? So parametric studies are probably the best use case on that point. So you've already hit the nail on that particular head. Though you can see applications for it with just having people be able to talk to each other a little bit better, having an interconnected place where you can do all of these things. So when I say interconnectivity, I don't necessarily mean a human removed process. which can have the connotation of that. I mean, it makes it easier to talk to other things. So like if I'm able to speak with, another designer in a much quicker way, I can send a message, I can show a mock-up on a specific part. Is this design okay? What do you think about this? I'm going to change the material to X, Y, or Z. Like that is still more feedback that you're getting directly into a system. So there's some other applications like that, but that is, again, one of the things that we at Dassault are doing.
Yeah, so not just feedback in the simulation, the software is not getting the feedback, just your company itself is getting that feedback faster and communicating that faster. And I mean, if you compare a lot of the times when I would do simulations, I know I was taking about 100 screenshots of every different angle and different plot that you could get and different section views and everything. So having that feedback directly accessible can make a huge impact.
Yeah, and again, it's all about saving time. That is the currency that we use, and it helps to make products faster.
And connect people that traditionally wouldn't be able to interpret that data.
Exactly.
So obviously there's a wide range of different simulation tools. I mean, we've established that, right? You can use simulation in different aspects of the development process and different aspects of your business. But cool. It's awesome to have cool software.
It's pretty cool.
Right? But how important is it to have the right understanding of the software, the right training around the software, and how to utilize these tools? I mean, I think that it's super important to make sure you have access to the right tools. But can you talk around a little bit about, some things to consider as you're getting started with simulation, maybe some research that needs to be done, training, whatever. I'll kind of open it up, but aside, pairing really closely with software, what type of knowledge, training, if someone's looking at getting into simulation, should they consider?
Another good question. So the way that I typically talk about simulation, especially if someone's just getting started or if they want to learn more, is that it's a language. For example, if you don't know what a mesh is, that's probably a good place to start. But understanding the basic building blocks of what makes a simulation function is crucial. Because at the end of the day, we're trying to do the same thing whenever we simulate a product. We're taking a big, complicated real-world physics problem that happens, on a molecular level, and we're taking it and breaking it into bigger bite-sized chunks so that a computer can solve those problems. If you can understand some of those building blocks in most fundamental courses, regardless of what discipline that you're studying, regardless of what company you take it with, will give you those fundamental building blocks. The rest of it is just understanding the accent, as it were. I guess if that makes sense.
Do you feel like over the years that the barrier to entry of getting started with a new software in simulation has decreased, or do you think that it's been pretty consistent with what you need to know before you can get started with simulation tools?
Oh my gosh, it has gotten so much easier to get started. So when I first started, things were very manual. I had to go in and specifically define element points. I had to make my mesh a little bit more refined here or there. I had to specify what specific chunk of the study that I wanted to do, all of these things. So again, with the automation and interconnectivity between products and softwares and people, it has not removed those tasks because those things are still happening in the background, but there is less of those very specific things that I have to do. I've automated a lot of those processes. So now I don't have to go in and specify every single element. I don't have to build a mesh from scratch, right? It'll do that for me. If I want to tweak some variables, I can do that. I can run a lot more things at once. So every single year, every month, simulation softwares get easier to use, which is amazing.
And another thing that people don't always consider is not only do you need training in the software, you should also have some fundamental knowledge of what you're trying to simulate and approximately where it should be, because it's super dangerous for somebody to just go in and plug in some forces and some fixtures and say, that's about right, and have no idea if it's at all within scale.
You can get some colorful rainbow-colored parts, and
it
looks great.
Didn't fail, looks good. And then you had it fixed completely at the bottom and didn't take into consideration a real world scenario.
Yeah,
that is interesting. Your comment there, Drew, about how simulation software becomes easier to use monthly, in just looping that into technology in general, increasing, becoming more capable, but also potentially more usable or the user friendly. So you mentioned saving time. Simulation is used to save time in the development process, not making wrong parts. You're being more confident when you're sending things out to the floor, not having to do multiple iterations of prototypes. But also because if you are running the latest kind of software solutions out there, your engineering development team is saving time as well because they're leveraging tools that are that much easier. They remember, you can templatize, you can set up scenarios that are that much easier to use than they were a year ago or even a month ago. So you're saving time on both ends by leveraging the latest tools. So I guess, Drew, as we're kind of getting into the simulation topic, engineering, the business size, there's multiple different software solutions and simulation tools. Like, should a small business with, a contract engineer, can they even get access to this type of software? Like, is this only for the big guys that have big budgets?
Oh, that is, you just fire questions today. I'm loving this.
Yeah.
So the answer is it's for everybody. It's for the big guys. It's for the little guys. One of the things that we at Dassault really kind of pride ourselves on is scalability. So we have solutions for people to just get started. Like if I'm someone that has no experience with running any kind of simulation, but I have a little bit of an engineering background, I can jump right in head first and I can get a pretty good understanding of it. Obviously, I would recommend training classes, but like you can just kind of poke around and you can get some answers. And then as things get more complicated, as the problems get more expensive, I guess is the best way I can describe it, we can also facilitate that. So if you are trying to run a huge crash analysis of something, right? Maybe I am designing Formula SAE cars. We'll do that, right? And I'm trying to see if this thing crashes, if it's going to kill the driver, which is probably something that I should know before I put somebody in there, right? I have a solution that's a lot more complicated that can handle that. And takes a little more setup, obviously, like there's more things going on, but it's scalable, whatever you need.
I love that scalable kind of comment too, because as we're thinking about the platform, 3D experience, simulation on the platform, design tools that are connected to the platform, that's just what I love about it, is the ability to have a scalable solution. You can jump into it on a quarterly, on an annual basis and start to get things connected. And as that project or those tools start to expand, you start to add and move roles around, and it gives you some of the flexibility and the scalability there.
I mean, a lot of the people have a project once in a while that requires something way more advanced. It's not their consistent day-to-day. So, I mean, you can weigh that out, and if you know that project is coming, upgrade to a higher capability and throttle back when you don't need it. And I think a lot of times people just need to talk that out, and like in their mind, they're like, oh, this is the biggest problem I have, and I need this all the time, when really it's just like 1 month out of the year they have a project that comes up that needs really advanced capabilities, and lower end capabilities, not even lower end, just less advanced, less intricate, can take care of and solve their problem just fine.
But what would they need to have in place before you could just turn on a role of simulation, in that realm and have it connected, right? You would need access to the platform. You would start to work your way through. Obviously, there's simulation tools that are outside of that as well, and desktop simulation tools and powerful simulation tools. But really, where you're saying that is you are working in design, you're saving your data to the cloud, and then you have the ability to turn on a role for a couple of months and run some simulation tests. Is that where you're kind of getting at?
Yeah, I mean, there's simple to really complex simulation, and you can have a simple one all the time, and then turn on, connect to the things that are already in the platform, and then run your simulations, and then turn it back off when you don't need it.
Which is not an uncommon workflow. There's a lot of people that do that.
Right. Matt, I'm going to give you the opportunity to ask one question to Drew, because apparently he said I was firing away questions and they were just coming off and making you think too much too. But Matt, opportunity here, and then we'll close out. Drew, I really appreciate your time.
Yeah. So when you're talking to people, that complexity scale, what's one of the primary things that you would look to quantify how complex their problem is? What are some of the main things that somebody would look at?
So the simplest way I can put it is whether or not stuff is moving that's not supposed to move, or stuff that is moving is supposed to move. So the engineering words for that would be static or dynamic, right? So if something is static, generally speaking, it's stationary and there's a load on top of it or on the side of it or whatever, right? If it's dynamic, that load is moving, the force. So if it is a dynamic load, then typically speaking, it's going to be a slightly more complicated problem. Now, there's other intricacies that can come up in there if you have a specific material type. So like if you're trying to understand what's going to happen and you have a system that has like an O-ring seal on it, right? So a rubber component that is getting out of the realm of isotropic material properties. That is to say, your parts don't have the same material properties in every direction. That gets into a more complicated simulation. So for people that are just doing, I want to make sure that this metal part that I have is not going to buckle or it's not going to break if I have it in a fixture or something like that, you can get away with a more simplistic simulation. It's a little easier to set up. For those engineers watching or listening, if you remember your college training in free body diagrams, that's basically what you're doing, but with extra steps. I mean, it's easier, but extra steps. As we get more complicated, that's where you get into your high-end simulation, and that's a tough term because it's not exactly the true thing. It's like high-end. It's more complex. More stuff is happening.
Yeah.
Well, with that, Drew, again, thank you for your time. Very fortunate to have you here in the studio having this conversation, and definitely interested in continuing the conversation in the future. And yeah, thanks again.
Thanks for having me. This was great.
Thank you.